Hello everyone, I'm thrilled to present my Capstone project here, which is Ad-Nexus Intelligence. The project was developed as a part of intensive hands-on challenge organized by Databricks and the Indian Data Club in a collaboration with Codebasics. So my goal was to build a production-grade data ecosystem that bridges the gap between a raw data engineering and real-world business impact. Okay. In a fast paced world of ad tech, the biggest enemy is wasting an ad inventory. Traditional systems rely on manual static rules that cannot scale or adapt to shifting users' behavior, resulting in billions of wasted impressions. So I have framed this as a binary classification problem, predicting the probability of a click based on a real-time user context, demographics, and campaign affinity. By moving away from a rigid rule and towards an AI driven approach, we can accurately identify high value users and maximize advertisers' return of investment and ensure that the right ad reaches to the right person at the right time. So before getting into my project, we might have seen these type of ads whenever we were open an application. Like for example, in an e-commerce website, you search for some specific phone, but the other phone brands are coming in. Like for example, Samsung here and Vivo ads are coming, and for the chair as well, and as well as for the pizza. Food delivery app. Okay, so we are seeing the promoted ads are coming at top to promote their business and to increase their revenue. Okay, so likewise in YouTube as well, we can see the multiple kinds of ad. There we have seen some relevant ads. Here we have seen that ads genres are totally different here. But in Instagram, if you can see the genres are related to same. I mean, for example, here it is again education related, and here also it is an education related. So they chose that I am the target user for this type of ads, and they have shown in my application. Likewise, for our own any e-commerce website, we have to show the relevant ad to the relevant person. Okay, let's get into our project first. So how ads work behind the scene? Okay, so whenever an user opens an application, anything, immediately the ad slot will send a request to the ad engine stating that for so and so aged person and gender, and for the location, do we have an ad? The ad engine immediately revert with a specific ad. Okay, uh, to fill that position. In between, multiple advertiser will fight for that ad slot based on the bid rate. Okay, so for example, one advertiser is asking for 8 rupees and another advertiser bidding for 9 and another advertiser bidding for 9.50. The 9.50 advertiser will win this bidding. Okay, so so how the ad engine knows this is the right person to show an ad? Because we have already an user profile with us based on the same relevant profile. For example, so and so aged person, so and so age person, so and so with a male category and from the city with a medium level phone range have already clicked an ad. So there are high chances that this person also will click that ad. This is the assumption will be sent here, and the ad will get filled by impression. And then if the user likes the ad, he will click on that and to know about more about that product, and that gets into a click. This is how at a high level the ad travels behind the scene in ad engine. So in last slide, we have seen that for each advertiser will bid for that specific ad slot. Okay. So each advertiser will configure their ad in an system based on CPM, CPC, and CPI. For example, CPM is nothing but for 1,000 impressions, how much I am ready to pay. And as like same for the clicks and same for the installs. Basically, installs will have the high value because uh, this is an high level conversion here. Okay, to for a person to install and making them to install an app is a high level conversion here, so the price will be very high for this.
Okay, we have to understand this, whether the campaign is configured based on the CPM or CPC and CPI. Whatever the model we are using here, it is based on CPC prediction. Okay, this is our even our project also flows like a user will open an app, and based on the requirement, the AI will predict the exact user and it will show the ad to the exact user. This is how our project also will work on this. So I have simulated the production environment with a 3-month synthetic data set of 1 million requests. And to demonstrate the data engineering river, I intentionally included a dirty data in this. Like, for example, null values, age will have null values and unknown values, and gender will have M and F, and also a male and female. I have intentionally make this data not clear and clumsy and a dirty data. I have included a multiple dirty data. Okay, so I'll just explain how this works. Okay, for example, as soon as a person installs an app, we will get his details, basic details. For example, we will create a user ID for that user. And there are two profiles we will create. One is app genre and another one is user profile. Okay, app genre will have what are the apps he have and what is the category and what type of genre he is searching in an application. For example, in YouTube, if he's mentioning some education related keyword and searching for that, then automatically this primary genre will become an education interested user, and the secondary genre is sometimes most probably the entertainment. Okay, and in user profile we will pick his age range, gender, and state. This everything is like see, sometimes the user will provide the data, sometimes we have to predict the data. That is a different concept here. Okay, but mostly in a companies, if you can see, 50% users data will have the proper data, and the remaining 50% are calculated one. Okay, and as well as we have another table called campaigns, where we will mention our campaign details. What is the campaign type? Like I have already explained, the CPC or CPM, whatever it is, and the billing rate example. Okay, and this is my funnel based architecture. Okay, from where the request is converted into impression and then it converted into clicks. This is how our data modeling looks. Okay, we'll move to next one. So in our data breaks, we will follow the medallion architecture to understand at a layman level. I mean, we can consider a muddy water, river water, has been cleaned using some RO technology. Then we will feed some minerals into that water to make it as a ready to drink that water. Okay, so basically, bronze is nothing but a muddy river water, which is our noisy CSVs, and silver is a filtered water, safe to look at. Okay, and cleaned, and then gold is like it's ready to drink in a packaged bottle, added with the minerals, etc. And the same thing we will follow here, like how we have converted our CSV into bronze table. The backbone is a medallion architecture here, managed via Unity Catalog for the strict governance. And in bronze, we have a raw ingestion of CSVs into delta tables. And in silver, we have where the data quality lives. I implemented a PySpark logic for the data standardization. And more importantly, deduplication logic to mitigate click fraud, a real world necessity for any ad platform. Okay, then we'll move to gold. So here I'll explain my project step by step procedure, how I have done this, how I achieved this. Okay, so I have uploaded all my relevant CSVs into volumes. Okay, in these volumes I have all the CSVs you can see here clearly. And then what I have done, I have created a delta table for the same thing. You can see that in our next slide highlighted here. Okay, just ignore these gold ML features because these are all created later apart. Okay, so campaigns, clicks, these are all delta tables which satisfies the asset properties. Okay, and then we created a silver ad funnel and and combined the request, impression, and clicks part here. Okay. And then we have done some cleaning part here as well, like converting the male, female to a common terminology like M and F. And then we have created an ML ready table for the ML related feature. Okay. And it has a clean data and it has a relevant columns with all related things. Okay. We transform data into intelligence here, and I engineered a custom affinity match feature which calculates the alignment between the user interest and an ad category. And also by extracting the hour of day and device type signals, we convert static database records into a rich feature set ready for machine learning properties here. Okay. And then in a medallion architecture, I have created the another goal table for the BI reporting for an ad hoc queries and for the sales and how my previous campaigns performed, what is the demographic, geographic performance for the past campaigns and for the advertisers as well. Okay. And this is my sample SQL dashboard where we can easily mention our query in a natural language, but just mentioning that what is my campaign level revenue and what is my state level revenue based on the billing rate, what based on the calculation behind the scene for the CPC, CPM, and the CPI. These calculations are done in the behind the scenes. Okay. And this is an another sample reporting BI dashboard for the sales team or to showcase the performance to the advertiser. Okay. So the final stage for the ML part, I have chosen the random forest model. Random forest model, why I have chosen this means, for example, out of 1 million requests, okay, the chances of converting those into an impressions, okay, if ad engine behavior is very good, 80% will get converted into an impressions, okay. But from the 80% to a click, okay, that is like 1% only. Okay, a percent, I mean, the CTR click through rate is 1% to 2% is a very good CTR rate. Okay, so I have chosen this random forest uh, classifier for its ability to handle a non-linear relationship in user behavior. Because the click data is highly imbalanced here, I used a balanced class weight strategy to ensure the model doesn't ignore the click events. Using ML flow, I tracked our progress to ROC AOC as 0.778, which is 70% is our model is performing very well, proving the model strength is distinguishing high value users from the casual browsers here. Okay. If the same thing I have done through the code and the results are shown here, okay, and understanding the ROC and the AUC, for example, one clicker versus non-clicker, okay. If I have a multiple non-clicker, I will rank them, okay, like point 0.5, 15, 40, 53, and 72. If there is a clicker guy comes in, I will give a high score to him. Okay, so that my prediction will work better here. That's why we got this 0.778 accuracy in ranking.
The same results we are seeing here as 0.77. Okay, we'll move. Quickly we'll see how I have built this project based on the ER diagram, how it connects between the table. The transaction tables are request, impression, and clicks in a real time. And from the ML part, the user profile and the app genre are contributing more to select the exact user. And this is from CSV to bronze table, and then generating the file, how I have generated the file, and then in a silver table, how I have cleaned the data, and in gold, how I've created the gold ML part, and then in ML model, how the model worked. The rating score is 0.77, and I have created a balanced part here to consider the click users as well in my model forest model. And then I tried to predict the, I mean, I tried to tried to do the simulator part here with the mail, and there is no click probability here for the same. And for the BI reporting level, user can go ahead and type a natural language, give me the state level data, and the BI dashboard also I have built for the same. These are all the main components in my project. Thank you.
To wrap up, this project demonstrates a full production life cycle from raw logs to Delta Lake optimization table to ML flow tracking and BI. The system is fully reproducible with all assumption and logic documented in my README section is there in my GitHub also. And thanks for your time in watching this. Thank you.